Yes, we are at day 11 today. So in this class, we are going to continue the serial UR programming. Fine. So as we had 1 day holiday in between the validated course, you people may forget. Okay, how to configure the SFRs, how to configure the serial UR by writing some value in the SFRs. Okay. So now we will refresh it and we will go with today's session. Fine. So in the previous session, we have programmed. Yes, we have programmed dot matrix display and a multiplex 7-segment display. Yes, to show different things on it. Fine. So in this class, we are going to continue with serial UR. So what are the features of serial UR we are having in AT89S52? Yes. Can you people say whether it is half duplex or full duplex? Yes. Yes. Whether the baud rate is fixed or we can vary. Whether the baud rate is fixed or we can vary the baud rate. Full duplex serial UR we are having, very good. So regarding the baud rate, whether it is fixed or we can vary. Yes, variable. Fine, very good. Okay, fine. Dixon kindly correct it. It is baud rate, BAUD. Okay, varying baud rate, BAUD baud rate. Fine. Fine. What are the SFRs we are having to program in the serial UR? Yes, what are the SFRs we are having? What are all the SFRs we are? Yes, very good. SCON. Then SCON is used to configure the operation, mode of operation of the serial UR. Yes. What about the other registers? In which register we have to place the data so that it will be transmitted, or if the data is received, which register we have to read the input data, serial input data. Yes. Kindly respond. SCON we are going to use it for programming. Fine. PCON we are going to use for double the baud rate. Yes, the MSB bit of PCON we can use it for double baud rate. Fine, very good, Lois Nega. SBUF register is the another register we must use so that we can send or receive the data. Fine. Physically, how many SBUF registers will be there? Physically, yes. Physically, how many SBUF registers will be there? Kindly respond, students. The previous class only we have discussed. Without knowing such things, it's not able to understand how to program the serial UR. Whether we have one SBUF register or multiple SBUF register. If multiple means how many numbers, what is the purpose of having multiple registers? Yes, very good, Lois Nega. We have two SBUF register with single naming. Okay, how it can be addressed? What are the two things we are having? Why we are having two things? Yes. Yes, read only, write only. One is read only, the another one is write only. Which one we are going to use for transmitting the data? Transmission means we are outputting the data, we are writing the data. Yes, which SFR will be used? Yes, write only SFR. Correct. Similarly, whenever I receive a data, whenever I receive an 8-bit data, it will receive at the SBUF read only. So we have to read that and we can understand what about the data we receive. Fine? Fine. So these are the three registers we are having. Out of this three register, which one is bit addressable SFR? Out of this three register, which one is bit addressable SFR? Yes, SCON. Fine. That means each and every bit in SCON you can set or clear individually. Fine. Okay. So we will go with the word format. Okay, quickly we will go through it. SM0 and SM1. For what purpose we have to use of this? Yes, for what, which purpose we have to use this? SM0 and SM1. Yes, to set the mode of operation. Totally, how many modes of operation we are having? How many modes of operation we are having? 4 modes. Very good. So to select the modes of operation, we are having this 2 bit SM0 and SM1. So according to the different modes, mode 0 means shift register mode. We are not going to use it. Fine. Mode 1, it's 8-bit UART with variable baud rate. Fine. Mode 2 and mode 3 are 9-bit UART, but in the case of mode 2, it is fixed baud rate. It depends upon only the oscillator frequency, I mean the crystal frequency. Fine. Whereas regarding the mode 1 and 3, both are going to have the same method for baud rate generation. Regarding baud rate generation, mode 1 and 3 are similar. Regarding mode of operation, mode 2 and 3 are similar. Mode 2 and 3 are 9-bit UART with same operation. Fine. Regarding baud rate, mode 1 and 3 are same. That means the same method we can use for generating the baud rate. Is the things are clear up to this? Yes? Yes? Okay, fine. What about the purpose of SM2 bit? SM2 bit, we are not going to use in our programming now, fine, but we have to know it. What about SM2? Yes, multiprocessor communication. Yes, multiprocessor communication mode. To enable or disable, we can go for SM2. Fine, that's it. Fine. See, when you are using SM2 bit as 1, when you are setting the SM2 bit as 1, so it will enable the multiprocessor communication mode. What you people have to do is you have to go for 9-bit UART mode with multiprocessor communication. Yes, that works fine. Fine. So that you can have multiprocessor communication environment. Fine. Coming to the next bit, REN. What about that? Yes. What about the bit REN? Yes, enable reception. To enable the reception, if I set the bit REN equal to 1 means it will enable the reception. If I set it as 0, it won't receive any interrupt. Fine. Okay. So set by software, reset by software. Both can be done by the programmer only. Fine. Okay. TB8 and RB8 don't consider now. So when you are going for 9-bit UART, for transmission reception of the 9th bit, you are using TB8 and RB8. Fine. Okay. The last 2-bit, PI and RI. Yes, PI stands for transmit interrupt flag. When this bit will get set, it is set by hardware. User have to clear it. Why? It is set by hardware, but user have to clear it. Why? Whenever I am writing some data to SBUF register, it will start transmitting. Yes, one by one bit it will start transmitting. After it has transmitted a byte of data, what it has to do? It has to inform the CPU. Yes, 1 byte of data is transferred successfully. For that purpose, it is generating an interrupt. Yes? Fine. Why we need to reset? If interrupt occur when going to ISR, the other interrupt service routine automatically reset the flag bit. Yes, regarding external interrupt or timer overflow interrupt, automatically when it enters into the ISR routine, automatically the interrupt bit will get reset. Fine. But in the case of serial interrupt, it's not like that. Why? Yes, any answer? Whether we have different interrupt for the transmission and reception in 8051. See, like external interrupt 0, external interrupt 1, timer 0 overflow interrupt, timer 1 overflow interrupt. We have only a single interrupt for both transmission and for both transmission and reception during serial communication regarding 8089S52. Fine. So we need to identify whether the interrupt is due to transmission or reception. That we have to find out. For that purpose, it is under the control of the software or by the user. Fine. Okay. So in mode 0, this and all no need. You simply understand. At the end of transmission, you will be getting TA bit set. Fine. Similarly, RI gets set whenever you receive a byte of data. If the serial reception is enabled. Yes. Okay. So we already discussed about this. We need to configure. Yes, we need to configure the serial UART of 8089S52 in mode 1. Yes, in mode 1 with the reception enable and disable multiprocessor communication. Yes, what about the bits? The previous class only you people answer. Just try it out. Mode 1, I have told SM2 bit what you have to do. I have to disable multiprocessor communication. Then I have to enable the reception. Yes, all other bits initially we can reset. Yes, very good, Logus Nagar. The MSB 4 bits are 0, 1, 0, 1. Very good. Fine. The lower 4 bits we can initially reset. So what about the data we have to write? Yes, very good. 0, 1, 0, 1, 0, 0, 0, 0. Very good. Super. Fine. So now what I am going to do is I am going to form this data. So it is going to be 50H in hexadecimal. So this value where I have to write in the SCON register, I have to write. Fine. Is it clear up to this? Yes. Okay. Fine. Very good. So how the baud rate in mode 1 we have to generate is through the timer. Yes, we are having two timers. Which timer we have to use to generate baud rate for mode 1? Regarding mode, yes, very good, timer 1. So how it can be defined is baud rate is equal to 2 power S mod divided by 32 multiplied by FOC divided by 12 timer 1 overflow rate. So this is the formula, usual formula. Yes. So timer 1 overflow rate. What it means timer 1 overflow rate? Whenever the count reaches the maximum value, the next pulse, yes, it will change from FF to 0, 0. Yes. So at that point of time, it will generate the overflow rate. Fine. So here I am considering the timer 1 must be configured always in mode 2. That means auto reload mode, it has to be configured. Yes. 8-bit timer with auto reload. See, when I say I have to program the serial UART of 8051 or 8089S52, obviously I need to program the timer 1 so that I can achieve variable baud rate. Yes, we can change the baud rate based upon the timer 1 overflow rate. Yes, can you people see from this equation, the baud rate of the serial UART depends on what are all the parameters? What are all the parameters we are having? SMOD, yes, FOSC, yes, then the count value. What it means? The baud rate of the serial UART of 8089S52 depends on the SMOD bit. If it is 0, we will be getting a normal baud rate 1 by 32. Yes, if it is 1, we will be getting 1 by 16. The very first parameter 2 power SMOD by 32 becomes 1 by 32 if SMOD equal to reset or SMOD bit is reset. If SMOD bit is set means 2 power 1, so 2 power 1 is equal to 2 by 32, which is equal to 1 by 16. Yes, so the factor become 1 by 32 or 1 by 16 based upon SMOD value. Yes, that is the first factor. Then FOSC, crystal frequency. Fine. So based upon the crystal frequency, the baud rate is going to be affected. Then timer 1 overflow rate. It depends on the count value what you are loading into the timer bar counter 1. Yes, fine. That's it about the baud rate. So from the baud rate, we have to know what about the value we have to load directly. Yes, 256 minus, why 256 minus? Why 256 minus? Actually what we will do, FF minus count value plus 1. Yes, FF is nothing but 255 plus 1 means 256. Yes, 256 minus this value. Or else you can do like this. FF minus this bracket value plus 1. Individually you can write. Fine. That's it. Okay, for example, you people find the count value TH1 for this particular configuration. Yes, timer 1 is configured in mode 2 to generate the bar rate for serial UART configured in mode 1. Yes, serial UART is configured in mode 1, which means what? Variable bar rate we have to go. Variable bar rate means we have to program the timer. Yes, timer 1 must be configured in mode 2. Yes, so the operating frequency is given, S mod is given. Kindly substitute and tell me. 256 minus 2 power 0 divided by 32 multiplied by 11.059 mega divided by 12 into 1 by 9600. Yes, have you got the value? Just substitute it like this. You'll be getting the value. Kindly respond. Yes. Mega means 10 power 6, we all know. So 11,059,200 becomes divided by 32 divided by 12 divided by 9600. It must be subtracted from 256. Yes, what about the value we got? See, this and all we have discussed in the previous session, but I am refreshing it so that you people understand why I am putting such values when writing the program. Yes, kindly respond. I'm waiting for your response. Why nobody is answering? Why this much time? I will check in classroom 2. Classroom 1, nobody answer. Yes, in classroom 2 also nobody answer. Why? You just substitute the values. I have substituted, just you have to tell the value. Why this much time? 11.059 into 10 power 6 means you have to multiply it by 1 followed by 6 zeros. Yes, 11,059,200. Yes, it has to be divided by 32, 12 and 9600. So the final value must be subtracted from 256. Kindly respond. Okay, I will go with classroom 1. If nobody responded, I will show it. 255.9. Kindly check it, Dixon. Kindly check it. You should get 253, I think so. To show the answer, no issues. Yes. If you convert it into hexadecimal, we will be getting FDH. So this is the value we have to load in TH1. Okay, fine. I will ask you one question. If I want to configure timer 1 in mode 2, yes, as a timer bar counter 1 in mode 2 as a timer without gate control, what value I have to write in the TMOD register? I will type the word format in the chat. Kindly you people make use of it. Gate followed by T/T bar followed by M1 followed by M0. So this again I have to repeat. Please refer it and tell me. Timer 1 mode 2 as timer. Yes, timer bar counter 1 in mode 2 as timer without gate control. Refer the, yes, very good, Anthony Surya, 20H, very good, fine. So these are all the things you must know so that you can able to program the serial UART. Fine? Okay. Can I ask you one thing? What you people did when you want to transfer some data in your Arduino IDE? Yes, with Arduino board. What about the line of program you people will use? Configure the baud rate. Do you people remember? Yes. See, when you are using serial, you are programming. Okay, in Arduino microcontroller. Yes, very good, Dixon. Serial that begin 9600. Okay, whether you people know, whether you people know what is happening behind this particular line of coding? Yes or no? It will do this function that everyone will know. Yes, obviously. Fine. How it is done in your program? What about the things happening in that function? Do you people know? Yes. So it's an inbuilt function available in the library Arduino IDE, so that we are directly using it. Fine. Whether we know what about the nature of the UART of that Arduino microcontroller? No, definitely no. Fine. So here we are writing the program. Yes, we are writing the program to do the same. Yes, to do the same 9600 baud rate, we have to fix it. Very good. Fine. Now, so what are the things we have to follow to program the serial UART of 8089S52? The very first step is you have to configure the SCON register. Yes, so that the mode of operation of serial UART can be fixed. Yes, for this, what value you people told me? What value I have to write in SCON register? See, generally we will go with mode 1 only regarding the SCON serial UART. When going for multiprocessor communication mode, we can go for mode 2 and 3. Mode 0 very rarely we can use. Yes, what about the value you have told? Previously we have discussed. Mode 1, no multiprocessor communication mode, reception must be enabled. You people already typed the value. Yes, what I have to load in the SCON register? Yes, very good, 50H, very good. Then program the timer 1 to generate desired baud rate. For this, what are the steps we have to do? We have to go into the steps followed in timer 1 programming. Yes, what initially we have to do? Initially what we have to do in case of timer program? Like this, I have told you some steps. Very first step, what we have to do? Yes, can you repair a vehicle when it is in running condition? Yes. Yes, first we have to make the timer 1 to turn off. For this, what we have to do? We have to make the timer 1 to turn off. First thing. What about the next thing we have to do? We have to stop the timer 1. Next, what we have to do? Next step. The very next step, you have to tell the mode of operation. Yes. When I am going for serial UART, I already told you, obviously we prefer to configure timer 1 in mode 2. Yes, carefully listen my word. Serial UART is configured in mode 1. But timer we are going to configure in mode 2. Yes, as a timer without gate control. Correct? So for this you people told one value just now. I think Logas Nega told just now. Yes, what value we have to load and to which register we have to load to configure the timer mode of operation. See, don't get confused. Even though I am programming serial UART, its baud rate generation is depending on timer 1 overflow rate. So that I can also program the timer. Yes, T mod is equal to 0x20. Very good, fine. So after that, what we have to do? We have calculated for 9600 baud rate, what value we have to load in TH1. Yes, just before we have discussed. Yes. So T mod is equal to 0x20. Very good. We have programmed the mode of operation. Next, we have to load the count value. Yes. What value I have to load into timer 1 register so that it will generate a overflow rate which will generate a baud rate of 9600. For that we have calculated already. TH1 is equal to 256 minus 2 to the power S mod divided by 32 multiplied by FOAC divided by 12 multiplied by 1 by timer overflow rate. TH is 256 minus TH1. Sorry, that baud rate value. 250 minus 2 power S mod divided by 32 multiplied by FOAC by 12. Okay, multiplied by 1 by baud rate. Which value we got? For generating the baud rate of 9600, what value we have got? FBH. So that value where we have to load up? In TH1. That's it. In TH1. That's it. Fine. Okay, what about the next step? Now we are ready to write a data or read a data. If I am writing some data, what I have to do? I have to wait till RI bit gets set. Then only I can do the next task. I mean, I can write the next byte of data. Fine. Similarly, when we are receiving, after receiving the data, automatically RI will get set. So regarding the reception, the microcontroller has to wait till a byte of data occur. Yes. For this, which function you people written in Arduino? Just compare. Whatever I am saying, it is in the form of a function regarding your Arduino IDE. Serial baud rate. Yes, for fixing the serial baud rate, we are having serial.begin function in the Arduino IDE. Yes, for doing that, up to step 2 we have to do. Fine. Regarding step 3, how you people know a serial data byte is available or not? Obviously, we have to use the hardware pin TX and RX for serial communication. I am asking the function. Which function you people have used? How I will know whether a serial data is there or not? I think some of you people are working in Arduino still. Yes, you people can reply. Serial.available. Have you used that function? Yes or no? What it means? At least 1 byte of data, if it is available, yes, it will start executing the next line. Okay, some data is there. We have to read it and we have to print it. So serial.read. See, these are the things you have done in the Arduino IDE. Now the same thing we are going to do with the microcontroller. Fine. That means any microcontroller, if you go, you will be having some set of registers. You should understand how to program it. If you people know that, you can write your own function. That's it. Fine. Okay. Now we can work with the program. So in the previous class we have started. So write an embedded C program to configure the serial UART of 8089S52 at the baud rate of 9600 and transmit the message welcome to KCE repeatedly at regular interval. Yes, shall we proceed now? Yes, shall we proceed now? Yes, fine. Okay, now I'm going to share my entire screen. Wait a moment. Okay, students, in the previous session I have told you we don't have a provision to check the serial UART output in MC82 IDE. Okay, we need some real hardware. So for this, what I am going to do is I have connected the hardware. With my another laptop. Fine. So in the module 3, I will teach you how to interface those things. Fine. I have used Bluetooth module which is connected to a microcontroller, 8089S52 microcontroller. Fine. So I am going to pair the Bluetooth connected in the microcontroller to my mobile phone. Fine. So I will do such things in later part. Fine. As of now, what I am going to do is I am going to go with the program writing. Okay. I am sharing my entire screen. Only you people tell me, is the presentation is visible or not? I mean, is my screen is visible or not? Yes, I hope my entire screen is visible. Kindly respond in chat. Okay, thank you. Fine. Now what I'm going to do is I'm going to open the software MC80 IDE. So we are going to send the message welcome to KCE. Yes, repeatedly through the serial UART. For this, I am going to write the program in this computer and I am going to transfer the program to my another computer. So there I am going to burn the code. So I am going to display the output from the mobile phone, from my mobile phone. Wait a minute. I will do all those things. First, we will go with the program. So in the previous session, we have started this program. We will continue with that. Okay, we will continue with that. Yes, very good. Okay, fine. So now you people see why I am mentioning this kind of things means if you are changing the crystal value based upon that, the value should get calculated. Obviously, to generate some of the bar rates, we must go for 11.0592 megahertz crystal only. Yes, the very first point or the very first line what I have written is I have included the header file. Yes, what about in second line I have did? Second line of the coding. Yes, what about second line of coding? What about second line of coding? Second line la enna pannirukkom? As defined FOSC space 11059200. What we have done in the second line of the coding? See, if you are writing a program like this, it will be easy for you people to make use of it in the main program or subroutine. I mean functions. Yes. Here if you change, everywhere it will get reflected. If I am changing 12 megahertz crystal, what I have to do here? Students, kindly respond. If you are responding, you people know very well how to program the serial UART. If you understand the serial UART programming, you will be good enough to control many devices. Okay, most of the higher end devices, okay, are using the serial UART protocol only. Fine. Yes, kindly respond. Second line la நம்ம என்ன பண்ணிருக்கோம்? What I have done? So you people responding, I am not going to proceed. Yes, kindly respond. See, if you people's not responding means I will stay with this. Okay, I won't continue. Am I audible in both classes? Is the presentation is visible? Just tell me. If it is wrong, we can correct. If it is wrong, we can correct it. What about this specific value? I have put FOSC before that. What it mean? (11059200). What about that value? Yes, very good. Frequency of the crystal. Yes, frequency of oscillation we are providing as an input. Fine. Okay. So on chip we have an oscillator. Externally we are going to connect the crystal. So this value is the crystal frequency. Yes. What about the next thing? Yes. What about the next thing? This value divided by 12. What it mean? எல்லாம் தெரிஞ்சிருக்கணும் கண்டிப்பா. Y divided by 12. FOSC divided by 12. What is mean by that? frequency of the input pulse is 110592, that I am dividing by 12. What about this frequency? Frequency of the clock pulse or something else? The frequency of the machine cycle. Why I am going for it? So that I can know what about the frequency input we are getting into the timer. We have studied when I am configuring timer bar counter as timer, it is going to count the internally generated pulse. So what pulse it is going to generate? For every one machine cycle, it is going to increment by 1. Correct? That means what? For every 12 clock pulse, we'll be going to have 1 pulse for the timer. So this is the timer clock input. Fine. So with this frequency rate only, the timer value will get incremented. Yes. So that value divided by 32 means we are again dividing it by 32 if S mod is equal to 0. Please remember, if S mod is equal to 1, what we have to do here? Kindly respond in chat. S mod equal to 0 means 1 by 32. So I am dividing by 32. If S mod equal to 1 means what? 2 4 S mod divided by 32. If S mod is equal to 0, what about the value of 2 4 S mod divided by 32? Substitute. Yes, 1 by 32. Very good. If S mod equal to 1, what about the value you will be getting? If S mod is equal to 1, 2 by 32, which is nothing but what? 2 by 32 can be rewritten as 1 by 16. Very good. In your program, by default, S mod bit is reset only. Suppose in your program, if you are setting the S mod bit, you can put a value 16 here. Fine. So now I am going to reset S mod. Fine. I am not going to use the S mod bit. Fine. Okay. Is it clear up to this? Just compare with your baud rate formula. You can understand what I have did. Yes. First, what I have did? 110,592 divided by 12. Correct? That is the very first thing I have done. That value divided by 32 now. Yes. So what about TH1? TH1 is equal to 256 minus. What about this value? FOSC divided by 12. Okay. That is equal to T clock. T clock divided by 32, which is equal to S clock. Yes. S clock multiplied by 1 by, what about 9600? Baud rate. Yes. We can do everything here itself. Fine. So I can define one more function as define baud rate. Yes, has defined baud 9600. Fine. So what about the count value you have to load? Has defined count. Has defined count. What about the count? 256. Okay, 256 minus SCLK divided by BAUD. That's it. Clear up to this? Students, is it clear up to this? Yes or no? Yes. So what about the count? Directly we can load. Count means for generating this particular baud rate, this count can be loaded directly. Fine. So initially what I am going to do is SCON equal to 0x50. This you people know very well. So I have configured the mode of operation of serial UART. The next lines, I am stopping timer 1, then the mode of operation of timer 1, I am writing 20H, that means 0x20. Then what about TH1 now? TH1 is equal to what? ph1 is equal to count. Just replace it. That's it. That's it. Here you can also put like this PL1, sorry, PL0, PL1 is equal to PH1. The very first time I am loading the count to both the register. Fine. The next time onwards, automatically it will get reloaded into TL1. Yes. Now I am enabling the timer 1. So now the baud rate got generated. Am I right or not? Yes. Is this thing is clear or not? Yes, fine, fine. Now I want to write a data, welcome to KCE, right? So what I am going to do is, I am going to create double underscore code on scar. Yes, it's a universal, it's a global variable. Yes, it's a global variable message. I'm giving the name as message. What message I have to send? What message I have to send? Wait a moment. Wait a moment. Okay, what message I have to send? Welcome to KCE. Yes, that's it. This message I have to repeatedly send again and again with a delay. Fine. So what I have to do is I have to have my delay program. Very good. Now what? Okay, later we will write these things. Okay, now you people help me. You people suggest me some logic so that I can write it. Fine. So while of 1. Yes, inside this what I have to do? Yes, inside this what I have to do? Inside this what I have to do? Kindly help me out. So first step what we have to do? First step what we have to do? Kindly help me out. Yes, the very first step what I have to do? Within this particular program, I told the logic already. I have to write 1 by 1 byte. Yes, initially what we have to do is whether we reached the end of the message or not. Yes, and you people tell me if I am declaring a string like this in an array. So what about the end character? How will you identify the end character? Yes, how will you people identify the end character? Yes, not equal to /0. Fine. Yes, null. The equivalent value for null in hexadecimal is equal to 0x00. Yes, 0x00. 0x00. Yes, is it clear up to this? Students, is it clear up to this? Kindly respond. Yes, fine. Yes, fine. Okay. So now what I'm going to do is if how I have to check. How I have to check? First, I have to take the data from the array. First, initially, what I have to do? I have to take the data from the array. Fine. How I have to take the data from the array? We have to declare a variable. Yes, character variable. We have to declare char val. Okay, char val. Fine. In this while loop, the very first step, what I have to do? I have to take the value from the array. How I am taking? Val is equal to yes, val is equal to what I have to write? I have to take the first byte out from there. How it can be done? Okay, I should have some reference. Okay, for that I am going to declare another variable to point the initial character. Yes, I equal to 0. Fine. To take the first data using I, what I am going to do? Val is equal to message of, or else I can go with for loop. Yes, yes, I can go with for loop. That's better. For I equal to 0, not for loop. While loop we can go, or else something we have to do. Fine. We should not have any count. End character we have to check. Otherwise we will go with this method itself. Wait a minute. Val is equal to message of I. Initially I made I equal to 0. Am I right? Yes. Now we have to check if val not equal to, if val not equal to null character. What we have to do? Kindly help me out. Initially I am reading the very first character. Whenever I am doing some repeated operation, I have to use some variable for pointing it. Or else you can use some pointer. Fine. Which one we can prefer? Whether we can use pointer or we can use this concept itself. Over data. Which one we can prefer? This one. Okay, fine. This one you people can understand easily. Later I will write the same program with pointer also. Okay, fine. Fine. Wait a minute. Okay, wait for some time. Wait for some time. Okay, fine. So now what initially I have to do is, I have taken the data. If it is not equal to null, sbuff is equal to val. That's it. That character. After writing the character, what I have to do? Kindly you people help me. I have to point. I want to point the next character. I want to point to the next character. For that, what I have to do? Yes. For that, what I have to do, students? Kindly help me. Students, kindly help me. What I have to do? Yes, very good. I plus plus. So I equal to I plus 1 I am writing, which is equal to I plus plus. Fine. After that, what I have to do? I have written the value in S bar. Okay. I have written the value in S bar. After that, what I have to do? Yes. Kindly help me out. Students, kindly help me out. After this, what I have to do? After I have written into SBUF, the 8 bit of data is going to be transmitted. Yes. After that, what I have to do? Just think about the logic. Just you people think about the logic. I plus plus பண்ணதுக்கு அப்புறம் என்ன பண்ணணும்பா? Just think and tell me. If it is wrong, we can correct it. No issues. No idea? Okay. How we can understand, how we can know whether the byte is transferred or not? How we can able to know whether the particular byte is transferred or not? Kindly reply. Yes, interrupt, very good. But I am not using the interrupt concept here. But still I can know whether the data got transmitted or not. Which bit I have to refer? Yes, which bit I have to refer? Which bit we have to refer so that I can know whether the data byte transmitted or not? So far we didn't discuss about the interrupt. Fine. But still we can know whether the byte of data is transmitted or not. Which bit we have to refer? I will check in classroom 2. Wait a minute. No response. See, SM2 is for multiprocessor communication mode. Dixon. See, what Logus Nega told is correct. No Logus Nega. RxD no. In SCON, one bit we have to check. And we have to wait. Till that gets set, we have to wait. Which bit? Yes? Any answers? I'm waiting for your answer. Which bit I have to set? Check. No RBA Logus Nega. See, I will type the answer while pi equal to 0. That means what? That interrupt occurs, okay, but we didn't consider about the interrupt. We didn't enable the interrupts. So with that SCON bit, okay, with the registers SCON bit, the register SCON, the bit TI, okay, we can able to understand when it will be 0, when TI will be 0, TI எப்ப 0 இருக்கும்பா? I have written 1 byte of data. Yes, still it is not transferred. Still it is not transferred. That means what? TA equal to 0. When it will get set? When TA will get set? Yes, when TA flag will get set? Kindly respond. See, you cannot able to use the interrupt now. Interrupt concept is something different. When transmission occurs, it will go to the ISR. That we meant it as interrupt service routing. Okay, but here what we are speaking? Here what we are speaking? Here what we are speaking? Kindly respond. Students, am I audible in both classes? See, today the response is very poor. Kindly respond me. See, when TA flag will get set after writing a byte of data, when TA will get set? When I write a byte of data into SBUF register, transmission started. That 1 byte of data, it is shifting 1 by 1 bit through TXD pin, right? After this byte got transmitted, obviously what should occur? Transmitting interrupt should occur, fine? But interrupt service routine, it won't go because I didn't program the interrupt. I didn't enable the serial interrupt, fine? So we manually check TA bit whether it is set or reset, fine? So if there is if the transmission is not completed, TA bit is equal to 0 only. That means what? Till TA becomes 1, I am going to wait in this loop. Is it clear to everyone or not? Till transmission completed, that 1 byte of data is transmitted successfully, I have to wait. Suppose if you people are writing next byte of data before the previous one got transmitted, what will happen? SBUF la na or 8-bit data potirukken. While it is getting transmitted, if you are writing another data, what will happen? At least answer for this. See, நீங்க ஒரு வேலை பண்ணிட்டு இருக்கீங்க, அந்த வேலை முடிக்கிறதுக்குள்ள நான் மேல வேலை கொடுத்தா என்ன ஆகும்? Yes. Is it clear or not? I have to wait till the 1 byte got transmitted. Is it clear or not? Yes, 1 completed, then only we have to do next. Yes, very good. The same thing here also. Yes, so we are writing a byte of data. First, what we are doing? Taking the value, checking it whether it is null character. If it is not equal to null, I am sorry. Here I did one mistake. Here val is equal to SBUF. Sorry, I am sending the value now. I am sending the value. So correct only. SBUF is equal to SBUF is equal to val. Okay. Because I have taken the message first character here. Yes, correct only. Correct only. Fine. So now what I have to do? Now I have to reset that bit that indicates okay, I can understand. So next time varappa TA வந்து 0 irundha it will wait in this particular while loop. For that purpose I am clearing it again. Fine. After this what we have to do? Nothing. So if val not equal to null, next character it will start getting Okay, it will check whether it is null character or not. If it is null character, it will skip out of this particular loop. If loop put velila vandum. I mean, in the if loop ulla pogadu. Else, what we have to do here? Else, what we have to do here? Else if, is it clear or not? I am transmitting the message and waiting. Okay. Else, what we have to do? If it is null character, what we have to do? It is null character, what we have to do? Yes, it will come into this while loop, getting the first character, checking whether it is null or not. If it is not equal to null, it is putting the buffer, then pointing to the next data, waiting till the first byte got transmitted, then resetting the bit TI. Fine. So this process continued again and again till null character occur. Fine. When null character occur, it will come to this loop, else loop. Fine. So inge enna pananum? We have to wait for some time. That is the very first thing we have to do. Correct? So here what I am going to do is next line print pandradhukaga here I am going to introduce, wait a minute, /n, \n. Okay. So if I put like this, what will happen? Yes, if I put like this, the next time it will print on the next line. That's the meaning for this. Okay. Else, I have to wait for some time. Again, I have to point to the first character. Correct? So I equal to 0. Am I right or not? These two things definitely you people have to do. Delay polana ennaagum. In a very faster way, it will start printing. In a very faster way, it will start printing. Fine. So that you people cannot see it. Fine. It will be running very fast. Fine. For that, I am introducing a delay like this. Okay. So after this delay, I am again pointing to the initial character. Is the program is clear or not? Yes. Is the program is clear or not? So delay I have to write. All those things are fine. Delay I have to write. Wait a minute. Void delay into the or first I have to declare the variable where I comma j or I equal to 0, I less than b, I plus plus. Okay, inside the loop, I am going to write another for loop for j equal to 0, j less than. Here I am putting a larger delay. Okay, because I am going to work in the hardware, virtual hardware, j plus plus. So here what I have to do is Amiru. That's it. So that's all about the formula. Can we compile the program now? Yes, can we compile the program now? Yes, fine. So now I am going to save the program. File, save as. Wait a minute. I'm not able to see the screen. Wait a minute. I think in the screen it's not coming. Wait a minute. I will check. File, save as. It's not coming. Okay, fine. I will use the same name itself. file, save, simply save. I'm clicking on save. Simulator, debug this file only. Yes. Okay, fine. We got some errors. We'll check it. Wait a minute. For this message column, I'm going to expand. Wait a minute. Okay, overflow in implicit constant conversion. Fine. Okay. So here we had one problem because we are dealing with character, correct? So TH1 we told it is a character, so it's a 8-bit data, but count definitely we can't do like this. So what we are going to do is, wait a minute, we have to declare one variable here, one more variable here, otherwise it won't work. Fine. B, I am declaring one variable B. Yes, here what I am going to do is, I am going to calculate the count. A minute. B is equal to, how to use the things. Wait a minute. B is equal to count. B is equal to count. So that value I am going to copy to here. Now we will check. Comparison is always true. Here I did one mistake, I think so. What mistake I have did? I equal to 0, I less than D, I plus plus, J equal to 0, J less than. Okay, here I have initialized it as a character. It's not a character, it must be integer. Yes, that two mistake I have did. Okay, now we will debug this. Yes, now it's fine. Now it's fine. Wait a minute, I will check my laptop. Students, wait for some time. My laptop screen is not visible properly. Wait a minute. I have to work on it. Okay, we can run this program in this simulator. We may not be able to see the output from the serial port, but we can see what are the things happen using step over function. I think my laptop, another laptop is having some issue. Okay, I have to do check. Fine. So instead of that, what we can do is we can do this later point of time, or else save program. Fine. Okay, now what I am going to do is I am going to click on step over. Actually, by today morning I have prepared my laptop. Okay, my laptop is having some problem. Okay, today morning only have the same fault. So I will do step over function. Wait a minute. Yes, here you have to see the time. Wait a minute. You have to see the timings. Fine. So now please listen. Please check on the screen. So first what I am going to do is I am going to press on F8. Yes. So kindly check about the SCON register. Where the SCON register is here. Yes, here we have the SCON register. Yes, so now it is going to be changed with the value of 51. Wait a minute. Sorry, 50. Yes. Okay. Next, check on the TR1 bit. It is already reset, so no problem. It's reset. Now coming to the TMOD bit. What about the content we are having? TMOD bit. Yes. Here you can see the TMOD bit. All contents, all bits are 0. So now I am executing. So it got 20H. Yes. Now what about the count we are having in TH1? Please listen. Yes, FD. Is it got generated or not? See, the thing is, what mistake I have did is, you can assign an integer variable to a character variable, but you should not write a thing into a resource. Fine. Here, count means in your system itself, it will calculate all those values. Fine. That means it will be substituted. Wherever I am using count, it will substitute 256 minus S clock divided by baud. For S clock, it will again substitute T clock by 32. Yes, for again T clock, it will be substituted by FOSC by 12. Like that, it will go. Fine. So, what I have did is, I am using a character variable initially. So, that is equal to count, so that everything will be calculated. So, the final result is going to be always 8-bit only. So, that value I am writing into the higher byte. Fine. Okay. Now, TL1 must also loaded with the same value FD. Fine. Both got loaded. Now, clearly observe. Now, carefully observe. Now, I am pressing on F8. Fine. So, the very first character. What about the very first character? What about the very first character we are having? In the message, what about the very first character we are having? Wait for some time. I will adjust the screen so that I can see your responses. Yes, what about the very first character? W, correct. Okay, now where it should come? In SBUF register, it should come. What about the SBUF register? Where we are having the SBUF register? I have to check. Here it is, I think so. Wait a minute. So here accumulator, B register, TCON, everything is, yes, here we have SBUF transmit. It got, wait a minute. Okay, I will make it full screen. Yes, you can see. Initially, SBUF is equal to 0D, correct? So now you see. Yes. We'll be getting the value. We'll be getting the value where that value is assigned is. Wait a minute. I'll show you. Yes, it comes to accumulator. Yes, 57, which is equivalent to the ASCII value of W. Am I right or not? You people kindly check it out and tell me. Yes. You people kindly check it out and tell me. Am I right or not? The value 57 is equal to, yes, the value 57 is equal to the ASCII value for capital letter W in hexadecimal. Only check it and tell me. 57 comes here. Only refer and tell me. Yes or no? Yes, in decimal it is 87. That's correct. Fine. So now what is it is going to happen? Carefully observe. Okay, now carefully observe. Wait a minute. I'm having some problem with the screen. Wait a minute. It's not at all changing. Not able to adjust the screen. Okay. So I will move here and there. At least you people can see. Yes, fine. So now that value is not equal to null, correct? So where it has to be written? It has to be written into the SBUF transmit. Now it is having 0D. Please listen. Yeah, val not equal to null. Yes. Is it loaded now? Is it got loaded now? In SBUF, you can see the data now. If it is not equal to null, it comes here. Yes. Correct. Fine. Fine. So next what we are going to do is next step. F8, I am going to click on it. Please listen. Yes, next memory it has pointed. TI equal to 0, correct? Wait a minute. Yes, it is waiting. Yes, it is waiting. Yes, you can see the data got shifted. You can see here. Now it become 1A. 57. If you shift 2 times, what it become? Yes. Yes. Is it clear now for you peoples? You can check PI bit. Nalla gavanichingna theriyum. Now it is taking the data. W முடிஞ்சிருச்சு. அடுத்து என்ன பண்ணுது? 65, which is the ASCII value for E, correct? Capital letter E. Sorry, small letter E, not capital letter. Small letter E. The decimal equivalent is 101. Now you can see in accumulator. Fine. See, this program is working, but unfortunately today I am not able to show you the output due to my issue in another laptop. Fine. Okay. Not able to adjust the screen itself. Wait a minute. Wait a moment. I'm not able to adjust the screen. Wait a moment. Wait a minute. I will stop the simulation so that I can able to do. I think so. Yes. Now I can do. Wait a minute. I'm not able to see the chat. That's the problem I'm having. Okay, fine. Now I have corrected it. Fine. See, this program will work fine. Okay. By next class, by tomorrow class, I will show you the output. Fine. Okay. You people try the next one. You people try the next one. I have told you how to send the data. Now you people, what you have to do? Write an embedded C program to configure the serial UART at the baud rate of 9600. Whenever it receives a data byte as shown below, yes, if you receive the number 1, fine. If you receive the number 1, you should send the message LED turn on. As we don't have hardware with us, so we are doing like this. If I am sending a message as 1, your microcontroller will send a message LED turned on. Fine. Instead of this LED turned on, okay, what you can do, you can clear a bit. Yes, you can clear a bit where LED is connected. and you can send the message. That means what? LED on means one logic I have to send, correct? So LED will get turned on. If it is 0, LED should get turned off, so that you can build a home automation system using Bluetooth module. Okay, you can transmit it your mobile data. You can transmit data from your mobile to the microcontroller or from microcontroller to your mobile. A two-way communication, wireless communication can be established if you interface a Bluetooth device. Fine. That means what? From microcontroller, it is going to wait for a data, either 1 or 0 or whatever it may be. Yes, after you have received a byte of data, you have to compare whether the data is equal to 1 or 0 or some other thing. If it is 1, what you have to do? You have to send the message LED turned on. Yes. In the meanwhile, you can write one program to turn on the LED, so that in real hardware you can able to see. Fine. If I get the logic as 0, you should turn off the LED and you should send a message LED got turned off. Fine. If you type some other value 2, 3, 4, 5, 6 something else, it should respond invalid input. Kindly check it. Like that, you can build a home automation application. Yes, what you have to do? To the microcontroller, you have to connect some relay. The relay should be connected to the household appliances. Fine. When you are sending the value 1, your microcontroller will receive. Based upon the value you have written, it will turn on the particular appliance. Okay. And it will send a message LED got turned on. Fine. If you send 0, it will turn off the appliance and will send you the notification LED got turned off. If you send some other value, it should show error message, invalid input, like that. Is it clear? In the next class, surely I will show you demo. Fine. Sorry for today's session. I may not able to show the hardware due to some laptop issue, due to some issue in my laptop. Fine. Okay. We'll go with the next concept. So far we have discussed about the port programming, we know very well. Timer we did. Fine. Serial UART we did. Now we are going to get into interrupt. Yes. Yes. How many interrupts we are having in total? In 8051, how many interrupts we are having in total? Kindly respond. Kindly respond, students. Yes. Am I audible in both classes? Okay. Students, kindly respond. How many interrupts totally we have in 8051? Okay, 5 interrupts. Okay, 8 software interrupt. Logos Nega, here we don't have 8 software interrupts. Here we don't have software interrupts. Yes. Okay, kindly correct it. So totally 5 interrupts we are having. Fine. So with that 5 interrupts, what are the 5 interrupts? How many external interrupts we are having and how many internal interrupts we are having? Yes. You people told 5 interrupts. How many internal interrupts and external interrupts are there? Yes, 3 internal interrupts. Very good. Yes, 2 external interrupts. So the external interrupts are INT 0 bar and INT 1 bar, which are nothing but the alternate function of P3.2 and 3.3, right? Yes, P3.2 and 3.3, right? Wait a minute. Okay, fine. Wait. Okay, P 3.2 and the 3.3, right? Okay. So you are totally having 5 interrupts from 6 sources, fine, with 2 levels of priority. There are 2 external interrupts from the external I/O devices and 3 internally generated interrupts by timer bar counter and serial UART. Yes, we are having 2 timer bar counter. From each timer bar counter, we have 1 timer overflow interrupt, fine. Then we have 1 interrupt for serial UART, fine. Totally, we are having 3 interrupts. So the external pins P3.2 and 3.3 are acting as the external interrupts. So this is the default priority order. Okay, external interrupt 0 is having higher priority, whereas serial interrupt is having the very lowest priority. Fine. So this is the default order. You can program some of the registers SFRs available in 8051 so that you can change the priority order. Fine. So there are 2 levels of priority in 8051, the low level priority interrupts, high level priority interrupts. Right? You can group all the interrupts in either one of this priority level. By default, all those interrupts are belonging to low level priority interrupt. Among the low level priority interrupt, if you are having more than one interrupt, the default priority can be fixed by this order. For example, if I move serial interrupt as highest priority level, okay, then it is going to be considered as the most highest priority. Then external interrupt 0, timer 0, then interrupt 1, timer 1. The order can be changed like that. Fine. If I move the low priority interrupts, I mean lowest priority interrupts to high level priority, fine. See, we are having 2 levels, level 0 and level 1. Level 0 is going to be low level and level 1 is going to be high level. Fine. You can group all the 5 interrupts in either one of this group. Fine. So we are having this registers for programming the interrupt. Here we go, the interrupts IE, IP, I mean the register IE, IP, SFR, IE and IP are used to program the interrupts. Okay, so IE is used to enable the interrupts and IP is used to enable the assign the priority level for the interrupt. Okay, whereas the lower 4-bit of TCON register can be used as type of interrupt sensitivity, whether edge sensitivity or level sensitivity, that can be fixed. Okay, then apart from that, you will be having 2 flag bits. Okay, 2 flag bits. So external interrupt 0 and external interrupt 1 flag bit. By seeing that particular flag bit, we can understand, okay, which interrupt occurred and which interrupt is currently pending. Yes, all those information we can identify. Fine. So first I will go with IE register. So this register by default it is filled with all zeros. That means what? By default, what about the condition of the interrupts in 8051? Yes, kindly give me the answer. By default, what about the condition of the interrupts, whether it is enabled or disabled, initial condition? Yes, kindly respond. By default, all the 5 interrupts will be disabled. Yes, yes. We have to program this IE register to enable which are all the interrupts can be enabled. Fine. Please listen one thing. If I reset EA bit, fine, it is called as global disabled bit. If I reset EA bit, all interrupt will get disabled globally. Fine. If I make EA as 1, then based upon the individual flag bits, I mean individual interrupt enabled flag bit, the particular interrupt can be enabled or disabled. Fine. Say for example, if you set EX0 equal to 1, if EA equal to 1, then external interrupt 0 will be enabled. Fine. Similarly, it can be done for all the bits. Yes. Now our interest is to enable the external interrupt 1 and 0. Yes, we need to enable the interrupt external interrupt 0 and 1 in our program. Fine. Okay, next. Find the value to be loaded in IE register to enable all internal interrupts and disable all external interrupts. Yes. Can you people tell me what about the bit pattern you have to write into IE register so that all external interrupts will be disabled and all internal interrupts will be enabled? Kindly form the bit pattern, assuming the reserve bits hyphen port 0 fill form. Yes, kindly fill out. Students, kindly fill out. I'm waiting for your response. What value we should write in IE register so that we can enable internal interrupts and disable external interrupts? Yes, kindly respond. I'm waiting for your response. Please respond me. Am I audible in both classes? Yes, I think so. My screen is also visible. Yes. I think nobody responded. Yes. Yes, tell me students, what value I have to write in IE register? Yes, 93. That means what? Bitwise I am going to type 1001. Yes, 0011. Fine. Kindly check once, Antony Surya, is the bit pattern matches to EA1 definitely. Next 2 bits 00. I want to enable only the internal interrupts. Yes, what are all the internal interrupts we are having? ES, serial interrupt, ET1, timer 1 interrupt, ET0, timer 0 interrupt. So this 3 bit and this bit, totally 4 bits I have to set. Yes, very good, very good. 9A is the correct answer. Very good. 9A is the correct answer. So what value I have to write? 9A I have to write in IE register to enable internal interrupts and disable external interrupts. Okay. Can you people type in chat if I want to enable only the external interrupts, what I have to do? The reverse way I am asking. எனக்கு external interrupt மட்டும் enable பண்ணனும்னா என்ன பண்ணுவீங்க? Yes. If I want to enable only external interrupts. Yes, 85. 85 is the correct answer. Please listen. First bit 1, 0, 0. Serial interrupt I have to disable 0. Yes. This bit also I have to set 0. Fine. 1, 0, 1. 85 is the correct answer. Very good. Super. Fine. So like this you can able to enable or disable the interrupts. Yes. Like this you can able to enable or disable the interrupt using IE register. Fine. That's all about the thing. Fine. Now coming to IP register. Okay, here we can group the interrupts to either low level priority or high level priority, that you people have to decide based upon the requirement. Yes. For example, you consider if Px is equal to 0, fine, set பண்ணிருந்தீங்கன்னா அப்படினா என்ன meaning? High level priority. Fine. Reset பண்ணிருந்தா low level priority. You have to consider two boxes, two groups. Fine. Low level priority group, high level priority group. Suppose if I am setting the bit, that particular interrupt will become assigned as high level priority. Yes. If the particular bit is 0 means it is assigned to low level. Fine. By default priority, external interrupt 0 is going to be highest. Fine. And the serial interrupt is going to be the lowest. Fine. So using this particular register, you can program the priority order. That's it. Yes. You people can program the priority order of the. Okay, fine. That's it. That's it. Is the things are clear up to this? Yes. Okay, coming to this slide, same thing. Okay, now what you have to do? Assign high level priority to all external interrupt and low level priority to all internal external interrupts. Sorry. Assign high level priority to all internal interrupts and low level priority to all external interrupts. For this, what you people have to write in IP register? Kindly check and tell me. Yes. For this, what value we have to write? Respond பண்ணீங்க திரும்ப அதே மாதிரி பண்ணக்கூடாது. Kindly respond. I want to assign internal interrupts with high priority. Yes, external interrupts with low priority. What I have to do for this? Students, kindly respond. Am I audible? I think I am audible only. Kindly respond. 1A. Yes, very good, Anthony Surya. Yes, 1A, very good, super. That's fine. I hope you people understand it very well now. Okay, now we can be able to write programs. Now we are ready to write programs. Fine. Okay. Coming to PCON register, the upper 4 bit you don't consider. Okay, the lower 4 bit IE1, IT1, IE0, IT0. Fine. This particular bit, external interrupt 1 flag bit. That means what? Whenever external interrupt 1 occur, this bit will get set automatically. Fine. When the program goes to ISR, it will get automatically reset. This is the thing happen. This is the thing happen when an external interrupt 1 occurs. Similarly, IE0 is initially 0. Fine. When an interrupt occurs, IE0 become 1. Okay. Once it goes into the ISR routine, corresponding ISR routine, IE0 bit will get automatically clear. That's it. Fine. So these two things are nothing but the flag bits to indicate the particular interrupt occurred or not. Is it clear? Yes, students, is it clear? Yes. Is it clear or not? Clear. Okay, fine. I will move to the next thing. Yes, I will move to the next thing. IT1 and IT0. Fine. So IT1 for external interrupt 1. The type of the external interrupt. That means what? The interrupt can be either edge triggered, edge sensitive or level sensitive. Fine. If I want to have the interrupt to be edge sensitive, I have to put 1 to the corresponding bit. IT1 la na 1 potana, the interrupt external interrupt 1 becomes edge sensitive. Edge sensitive means what? When the pin P3.3, that is external interrupt 1 pin, okay, if it goes from high to low, it will be considered as an interrupt. That we call it as edge trigger. Yes, If it is set, that means yes, falling edge trigger. If it is reset, if the bit is 0 means it will be working as a low level trigger, level trigger. Is it clear? See, IE bits are flag bit, whereas IT bits are meant for what? To choose the type of the interrupt, whether it should be edge sensitive or level sensitive. For that purpose, we are having IT0 and IT1. Fine. Coming to the next slide. Okay. Similar for external interrupt 0. The same thing. Yes. Now you people try to write a value. Find the value to be loaded in TCON register to configure the external 0 as edge trigger and the external interrupt 1 as level trigger. Yes. All other bits you fill 0. I want to configure external interrupt 0 as edge trigger, external interrupt 1 as level trigger. What value you should write? Yes. Kindly tell me. Kindly tell me. So don't consider about the other bit. Consider only IT0 and IT1. Kindly tell me. The other bits you mark it as 0 alone. Fine, no issues. Yes, I'm waiting for your reply. See, the question is, I want to make external interrupt 0 as edge trigger and external interrupt 1 as level trigger. What must be the value I have to write in TCON? Consider all other bits are 0. You have to consider only IT1 and IT0. Already I told you, edge trigger means we have to fill 1. Level trigger means we have to fill 0. எல்லாத்தையுமே சொல்லிட்டேன், வேல்யூ மட்டும் தான் சொல்ல போறீங்க நீங்க. Yes. Kindly tell me. By this class, most probably you will end interrupt. Students, kindly respond. Yes. Why you are behaving like this, I don't know. It's a simple question only I asked, but none of you is replying. Okay, shall we wind up the session, students? See, if you people are not responding means for whom I am taking the class. Yes, Mohammad Hamdan is saying yes. Okay, Mohammad Hamdan, you can leave. Yes? See, without you people answering, I won't continue the class. Okay, after a long time, Anthony Surya is replying. What happened to you, Anthony Surya? At least you will answer always for my question. If you peoples are also doing like this, means to whom I have to take class. See, it's not a good thing. If you people are not interested, kindly tell me. I will speak to HOD sir, okay, and I will convey. They are not interested, sir. Okay, Anthony Surya, you are having network problem. Fine. What about others? Hamdan is saying we can wind up the session. Yes. See, I am struggling. See, I am struggling with my another laptop. It's not working. Otherwise, I will show you the output in today's class itself. See, is it a need for me? Is it a need for me to show the output? I can say this is the program. If you work in hardware, the output will come. Like that, I can see and go. Why I am doing all those things for you people? Fine, it's not a good thing. But anyhow, Anthony Surya, thank you for your answer. The answer is correct. Yes, IT1. It should be, I think it's wrong only. Yes, IT1. External interrupt 1 has to be level triggered. So it should be 0. Okay, external interrupt 0. It should be edge triggered. That means this bit has to be 1. Yes, 0, 1 is the correct answer. Thank you, Anthony Surya. Thank you. Fine. So kindly interact. Okay. Simply, I am not coming and teaching you. Okay, I am preparing more for taking this particular class. Okay. See, any one program can you people tell? Simply, I have directly explained. I am explaining line by line. That means what? You people have to understand. For that purpose only I am doing like that. For name's sake, I am not doing anything. For your kind information, I am telling. Okay, if you people continue not responding like this, okay, I will speak to HOD sir only. Okay, that's the only thing I can do. Okay. So 0, 1 is the correct answer. Thank you, Anthony Surya. Fine. So this is about the infrastructure of 8051. We can skip this. Straight away we can go for programming. Yes. Consider the above program, program 3. So consider an LED is connected at P2.0. Yes. Consider an LED is connected at P2.0. We have to write an embedded C program to blink the LED at regular interval. Yes. Yes. Is the program already we have done? Is this program already we have done? Yes or no? Yes, fine. Now we have to write an embedded C program to blink the LED at regular interval, which is connected at P2.0. Also, the LED must get turned off. Okay, off. It must be double F O double F. Okay, turned off whenever external interrupt 0 occurs. Right, and it should blink, keep on blinking when external interrupt 1 occurs. Fine. The initial state of the LED, it is going to blink only. Fine. When external interrupt 0 occurs, what it should happen? What should happen? LED must get turned off. When external interrupt 1 comes into the picture, the LED should again start blinking. Can we write a program for this? Can we write a program? Yes, very good. Fine. Okay. Fine. So I'm going to delete the entire program. I'm going to start using the interrupt. I'm going to use interrupt concept now. So far, we have checked only the flag bits. Fine. So now we are going to use the interrupt hardware. So first, I am going to include the header file 8089s52.h. ஒரு விஷயம் நல்லா புரிஞ்சுக்கோங்க. If you are able to handle interrupts, okay, you will be very familiar to handle many devices. Fine. Okay, so now what I am going to do is I am going to have one LED. So has defined LED pin number P1.0 or P2.0. Yes, that's it. So now I am getting into the main program. In the main program, initially what I am going to do is I am going to enable I'm going to enable the external interrupt 0 and 1. Okay. Kindly on seeing this particular thing, you people type in chat what I have to do for enabling external interrupt 0 and 1. Yes, you kindly go through this word format. Yes. Yes, you can go through this. I want to, yes, 85, very good, thank you. Fine. So now what I have to do? Which register I have to write? IE register. IE equal to 0x85. That's the very first line. Okay. Here I'm not bothering about the priority order. If you want, you can program it. Fine. Now I'm not bothering about the priority order. What I'm going to do is I'm going to declare a global variable, bit variable status. Initially, what I'm going to do is status equal to 1. Okay, status equal to 1. Here I'm declaring if status equal to 1, my LED should keep on blinking. Fine. If the status is equal to 1, my LED should keep on blinking. That is the very first thing I want. Fine. Okay. If status equal to 0 means my LED will get turned off. So that I am declaring a global bit status equal to 1. Now what I am going to do is I am going to write a program while of 1. Okay, while of 1. Here I have to check if status equal to 1 irundal, what it has to do? You have to write a program. LED equal to 0, some delay. Yes, after the delay, LED equal to 1. Yes, after the delay. So this thing will happen. If status equal to 1, always this thing will happen. Yes, is it clear up to this? Is it clear up to this? Else if, or simply I can go else. Definitely status must be 0 only. Status 0 is enna pannumpa. If status equal to 0, what you have to do? Yes, if status equal to 0, what I have to do? LED equal to 1. Thank you, thank you. Fine. See, don't think I'm scolding you people. Fine. If you people are not responding, how I can handle the class? Already we are feeling very bad. We are speaking in front of the system as a single person. Okay. Fine. If you people respond, at least we can have the feel. Okay, students are there, we are teaching to them. Fine. Okay. So that's it. Is this thing is clear? Main program. Okay, what I have to do now? When external interrupt 0 occurs, I have to make status pin as yes. If external interrupt 0 occurs, what I have to do? Status as 0. Yes. If external interrupt 1 occurs, I have to make status equal to 1 so that LED will start blinking. Fine. Okay, very good. Now what I am going to do is I am going to write the interrupt program. I am going to write the ISR. So far I have declared many functions. Now I am going to write the interrupt service routine function. It's very, very important. Kindly listen carefully. There is some syntax we have to follow in embedded C so that you can write interrupt service routine. Void, it should not return any value. First of all, you people have to understand the interrupt service routine. It should not accept any input. It should not return any value. Fine. So void, I can give any name. For example, ext0, external interrupt 0. Fine. This is the function I am assigning. Double underscore interrupt. This is very, very important. Double underscore interrupt. Wait a minute. Double underscore interrupt. Fine. After this, inside the bracket, you have to give one number 0 to 4. Fine. 0 means the very first interrupt, external interrupt 0. Fine. 0 I am giving. If it is timer 0 interrupt, you have to put 1. Fine. The very first priority interrupt, it is numbered with 0. the next priority interrupt, it is numbered with 1. Why it is like that means vector address is equal to, wait a minute. Here in the header file, they have written vector address is equal to n into 8. Wait a minute, n into 8. N into 8 plus 3. Yes, n into 8 plus 3. I have typed in chat. Kindly verify it. Now you substitute n is equal to 0. What value you will get? Yes. If I substitute n is equal to 0, what value I will get? Kindly respond. If n equal to 0, what value I will get? Substitute in this and tell me. Yes, 3, which is nothing but 0003H, which is a vector address for external interrupt 0. Is the vector address for external interrupt 0. Okay, we can see. We can see in the slide. Yes, here you can see. By substituting the value of n equal to 0, you will get the vector address of external interrupt 0. 1 means 11 you will get. The equivalent value is 000B, correct? Is this thing is clear to everyone? Why I have to put the number like that? That will provide the vector address of your interrupt. That's it. Fine. Okay, when this interrupt occurred, what must be the value of status? As I declare status as a global variable, I can use it in any function. So status is equal to 0 simply. Yes. Similarly, I have to write for external interrupt 1. Can you people help me? Can you people help me out? The same line of coding I am going to copy. What I have to change with this particular lines? Help me out. So for external interrupt 1, I am going to change it as 1. See, it's no need ext1, you can put any naming. You can simply put E1, E0 like that. Anything you can put, but it should give some meaning. What about the value I should put here? That's very, very important. What value I have to put here? So that n into 8 plus 3 will come as the vector address of external interrupt 1. 0013, which is nothing but 19. Okay, I should get 19 as the value. Fine. 8n plus 3 equal to 19. Calculate what is the value of n I should put. Yes. 8n plus 3 equal to 19. I have given the clue. Yes, 13 in hexadecimal, it is equal to 19 in decimal. Fine. 0013H, which is nothing but 19 in hexadecimal. Yes, very good, super. Thank you, Anthony Surya. Fine. So here I have to make status equal to 1. That's it. Thank you, Dixon. Super. Okay. So double underscore we have to put before interrupt. Then only it will consider. So this syntax we have to follow. So that's all about the program. Now I'm going to give the hardware connection. So virtual hardware LED panel I am taking. So 2 minutes la mudichidalampa. So with this we will wind up the session. Wait a minute. Yes, 2.0. I need to take 2 switches. Why? Yes, delay program we have to write. Wait a minute. Void delay of int. Yes, delay program we have to write. So int I comma j for I equal to 0, I less than b. So here I have to tell the variable. We'll tell it later. I plus plus. Here I have to put int d. See, inside this for loop, again I am going to introduce one more for loop for j equal to 0, j less than 15, j plus plus. Okay, that's all about the delay program. Okay, fine. So in the above, I have to declare this particular line. Wait a minute. So here I am going to write. That's it. Void delay. So it's a integer type. I'm going to pass. Okay, that's it. So I have connected LED at P2.0. Now I need to connect two switches. So what about the purpose of those two switches? Any idea? I told external interrupt, correct? So what about the pin numbers? P3.2 and 3.3, correct? P3.2. Yes, that is one pin. The another pin must be P3.3. Okay, is it clear, students? Yes, is it clear? Okay, fine. Now I am going to simply run the program. Wait a minute. Yes, one error I got. Compilation failed. I got one error. I will check what about that error. Wait a minute. Yes, here I missed out one semicolon. Fine. Now I will debug this. Yes, that's it. So now I am going to run the program. I will turn on this. Okay, now you people see LED is blinking. Yes? Yes? Okay, now what I am going to do is I am going to generate interrupt 0. Wait a minute. Yes, what about the condition now? If I generated interrupt 0 means what about the condition now? LED got turned off, correct? Yes, when LED should get blink again, if I generate interrupt 1. Yes, is it working now? Can you people see it now? Yes, is the things are clear now? Yes, that's it. Okay, fine. Thank you, students. Okay, now I'm going to stop the recording. See, kindly interact. That's the problem I'm having with you peoples. If you peoples are not interacting, to whom I'm teaching, I don't know. Fine. Okay, now I'm going to stop the recording. Wait a minute. See, if you people have any doubt, you can stay and ask. The next class, we are going to discuss about the LCD. Fine. So kindly